Hello everyone. My name is Abhinav Misalkar.
And I'm Himanshu.
This video is a part of the Python prototyping course at the Carnegie Mellon University, and it will explain you about the coding project used for the purpose of clean development mechanism. So, what is clean development mechanism? It gives you the privilege of earning certified emission reductions to a person or a company or a nation if they generate energy with zero emissions of greenhouse gases. Each CER credit is also known as a carbon credit is equivalent to 1 ton of CO2. This mechanism encourages the adoption and growth of renewable energy technologies like solar, wind, hydro, geothermal, etc. in various developed and developing countries. With the help of this project, we attempt to strike a balance between the cost of electricity and each carbon credit earned by the company, depending upon the electricity demand of the project and the source of electricity. So I think I explained you most of the parts. So cap is basically the limit set upon the amount of carbon emissions for a given company. Trade is basically the buying of carbon credits to achieve the carbon emission reduction targets. And looking at the past, a similar method was implemented to reduce the amount of sulfur emissions, and as a result of this implementation, the rate of acid rains have vanished to almost negligible.
I'm Himanshu and I will take over from here. So this is our project. So in our project, we'll take an input from a user, which will be electricity consumption in preferably kilowatt hour, and we'll give the user output, which is like how much percentage of electricity he or she should take to reduce its overall cost. So this is the code we have written. So in this, we enter your electricity consumption. So you put in your value in kilowatt hours. So we take a range and iterate it. So firstly, we get a Z1, which is cost of electricity, and we here try to promote wind over coal. So we multiply the electricity from coal, the value we get into the kilowatt dollars per kilowatt hour, and same with the wind. So in this case, we get Z1, which is a cost function, and this increases as we go from coal to renewables. But in the other case, it's Z2, which is CO2 emissions. This decreases as we go from uh, uh, coal to renewable. And here from the data we have taken, like if the kg of CO2 is less than is greater than 10,000, the multiplication factor is around multiplication factor is 3, which is roughly $30 per ton of CO2. So similarly, we multiply it by each slab market, and then later on we plot the graph. So let's see what we get here. Let's run the code. So this is so we get a electricity, enter your electricity consumption. Let's put in any random value. So this get a graph. So this was our initial state where 100% of uh, electricity was from coal, and as we go here, this is 100% of electricity from renewables. But as you can see here, these are the minimas, and this is the global minima, where around if you take 70% from renewables, your cost is minimum, and the value the difference between this and this value is the total cost you can save. So this is what we have done, and we hope to use OOP and GUI in the next processes. Thank you.